Last but certainly not least, we have Joe Sleppy here with Capacitech.
And thank you, and I'm sorry I didn't give Gabby fair warning, but my partner, Dr. Thomas, is also here today. We ready? Okay. Well, hello everyone. I'm excited to be here, and I'm very excited to present my venture, Capacitech. So over the last 6 months, Jane and I have sat down with many companies manufacturing power electronics in the IT industry. We're talking to them and they're telling us, listen, this is a mature industry. There's not a lot of innovation going on right now, and it's really hard to gain market share. So naturally I asked them, well, how would you gain market share? They said, well, our customers want our products to be smaller and more affordable. So after talking to their engineers, we found out that capacitors are a major roadblock to reducing the size and cost of power electronic products. Capacitors are essentially a special type of battery. They store just a little bit of energy that can be delivered very quickly. Capacitors come in many different shapes, many different sizes, and they're in almost every electronic device from your phone to whoever's got a Tesla outside. Well, being a manufacturer, holding inventory for all of these capacitors is actually really expensive. On a worldwide scale, it's about $800 million. We are going to save the world from high inventory costs by proposing a customizable capacitor. This is a capacitor that can be built on the surface of a copper wire and can be cut at different lengths to control the performance of said wire. Our capacitor, compared with another standard capacitor, is smaller. It is also going to be more affordable because you can buy large quantities of this capacitor rather than several different capacitors in smaller quantities, driving down the cost. So as I said, it's about 1/3 the size of an equivalent capacitor. It's lower in cost and it has less inventory cost because you only have one device in your inventory management rather than perhaps 20. So what we do is we take a bare copper wire and a bare copper foil, we go through our magic process and we wrap the two together to create our device. Now this process can be done on very long lengths and is very scalable. So what we're going to be doing is selling spools of wire. Okay? This spool of wire would then be sold to the customer. The customer would feed the spool of wire through a machine that will then bend and cut the capacitor based on the performance that is needed. The operator, or the employee, would be who puts the settings on the machine. This is not unheard of. They already have machines doing stuff like this for resistors and capacitors in machines today. So if we look at a real-world example, we have a capacitor on your left, which is just a simple voltage regulation circuit, and we have our version, which replaces those 8 cylinders. As you notice, there's a lot more blue space on our version versus theirs. That's increasing the real estate on the circuit board, which is very valuable because the customer could then add additional functionality to their product if they wanted to. But also, we have a lower cost. We would be able to reduce the size to be about 1/3 what they were currently doing. The inventory cost is less, and essentially, we would save $8 per unit, or $8,000 a day. That's very valuable. So this was developed by this handsome gentleman to my right. He was the inventor of the technology at UCF. Woo, that's right. Got amazing academic support, and what we realized was, okay, let's see if there's a market potential for it. So we went through the National I-Core program and validated that this is a real problem and this is a viable solution to that problem. I'm also excited to stand here for the first time publicly and say that as of 2 weeks ago, in exchange for 4% equity and a 2% royalty, Capacitech is the exclusive licensor of the intellectual property. So step 1, we're going to replace capacitors on power electronic circuit boards. This is because it is the fastest path to revenue for us. It is a simple and clear value proposition. But we want to do more than that. We're going to partner with companies that we sell our capacitor to co-develop new products. For example, we could replace capacitor banks on cell towers with a wire. By doing that, you reduce the rent that cell service providers pay to have access to their cell tower. We can also replace power cables that are in backup power systems. By doing that, you add another level of redundancy to backup power systems for an IT center or to a data center. But we would still be maybe a medium-sized company if we did these two things. I want to be a big company. So in stage 3, we are going to embed our capacitor inside a circuit board. By doing this, the customer no longer needs to buy, install, or manage capacitors. It's already in the circuit board. This allows us to scale to new verticals, and it would be a major disruption to the industry, which will likely result in us being acquired. So at first, we're going to focus on American power electronic manufacturers, a $200 million industry. Then we'll grow to global manufacturers and co-developing products before finally going into replacing capacitors to get to a $4 billion market size. Now, there are other ways to reduce the size and cost of power electronics. You could use a fancy, very expensive advanced capacitor, but oftentimes it's so expensive, it's not worth it for the customer to use them. You could also use machines such as the surface mount machine, but this is the standard way to do business now, so it kind of lost its transient advantage. Also, our capacitor provides more design flexibility, more manufacturing flexibility, and can help you launch new products. Power electronics manufacturing companies really value a diverse product line and a diverse intellectual property portfolio. To be successful, we need a launching customer, which we found in Ditech. This is a medium-sized company in St. Petersburg, Florida. Now, they've told us that they're very interested in this and actually led into talking about an equity investment in the company that will be matched by the Florida Institute of Commercialization. Now, Ditech wants to work with us because we can provide them a new competitive advantage, help them fortify and grow their market share, and diversify their product lines and intellectual property. We want to partner with them because they will likely be our first customer, and they help us give us a site to a real-world manufacturing facility that we can perform detailed case studies in. They did tell us that we cannot be a single source manufacturing company. We have to have another partner who manufactures this. So Jabil is a leader in contract manufacturing services who is investing heavily in advanced processes like our own. Now, Jabil, they've given us a letter of support. They're going to be our contract manufacturer. However, they also told us that they experience this problem on a daily basis because they install a lot of capacitors on a lot of different products. So they would like to provide us introductions to their customers in the automotive industry, healthcare industry, DoD, etc., after we have initial sales and strong case studies. So for the next 6 to 9 months, we're going to work with our partners, Sism Thin Films and Idea Engineering, Ditech, as well as Jabil, to design a mass manufacturing process for our cables. We will then go into a sales mode, going to trade shows, getting our UL listing, doing our first mass manufacturing run with Jabil, and eventually integrating with Ditech for our first bit of sales and revenue. However, I want to point out, around the middle of 2018, we're going to need an additional investment to fund the scaling efforts. So, 2017, we're going to be developing that mass manufacturing process with Jabil. We have to make sure that this is working first. But in 2018, we're going to do a paid pilot with Ditech. This isn't about getting strong revenue numbers in this year. It's about getting detailed case studies, which we will use to entice our next 5 customers in the next year. The first 5 customers will likely be a US-based power electronics manufacturing company that we will meet through trade shows and through connections of our advisors. But in 2020 is where we really scale up the revenue. We're going to partner with Mitsubishi. Mitsubishi is not an industry leader in power electronics, but they are definitely top 10, probably around 6 or 7. We're going to partner with them because it starts to change the way the industry looks on a large scale, forcing leaders such as Emerson and APC to either lose their placehold in the market or adopt our technology, which is how we'll scale the revenue. I also want to point out, in 2021, we will start to talk to Jabil about being introduced to new market verticals, and in 2022, we're going to explore licensing our technology to other capacitor leaders such as Maxwell capacitors. We believe we will be producing the capacitor for $4.20 and selling it for around $10. In 2018 with Ditech, just looking at their low volume product lines, we're looking to integrate to only 8% of their products to get us to our $100,000 revenue mark. But then we're going to scale to 5 medium-sized Ditech-like companies, which will get us to $750,000 in revenue, being integrated only into 15% of their products. Capacitech was founded by myself and Dr. Thomas. Dr. Thomas is a brilliant scientist, an amazing engineer, and he has the domain expertise that was extremely valuable in helping us secure those initial partnerships with Jabil. We also got a letter of support from Lockheed Martin and also Ditech. I am an electrical engineering student. I've been an entrepreneur since I was 16 years old. I started my first company then, got a $10,000 fund to launch that and get it into revenue. But I realized when I was so young, I have to surround myself with experts in their field if we want to be even remotely successful. So we have surrounded ourselves with advisors and mentors, many more who don't even fit here, to keep us on a path to success. Lastly, last year we won this version of the competition at UCF, the UCF Joust, and that gave us about $75,000 of unused services. So we have donated accounting, legal, CFO, and marketing services that we will be using to fortify our launch over 2017 and 2018. Thank you, everyone, and I look forward to your questions.
So playing in this industry, you're going to be providing capacitors and circuit boards that go into Lockheed for missile systems, Siemens for telecom, laser systems, etc. How do you control the mil spec of these products? Because the tolerances are so tight, and I saw a big spool of cable. Who cuts that to the exact tolerance that allows you to have a capacitor that is within those mil specs? That's the first question. The second, I thought you said that there's already machines out there doing resistors and capacitors. I didn't understand that, because what's different about you then?
Okay, so the first question was about meeting those specific mil specs. Our first customer is Power Electronics for this building, for example. So they might be voltage regulation, they might be surge protection, anywhere from a consumer's home to a commercial building, all the way up to the DoD specs. Starting at DoD would be very risky, and if you knew me when I started this company, that was our plan, and it's just too much risk to go after DoD right away. So we're focusing on people lower down the totem pole, where the exact tolerance isn't necessarily so critical and specific. As for the machine, I'm sorry if I explained that incorrectly, but what I was saying is that there are machines that currently bend and prepare components like resistors and capacitors, not our resistor and capacitor, but standard capacitors, so that they can be installed on circuit boards. So the point of that was to make it clear that if we were to tell a customer, hey, we're gonna sell you a spool of wire, here's a special machine that will draw our wire in, bend it, and cut it so it is at the right performance, the right capacitance, and that way you can install the capacitor that you need. They wouldn't think that's unheard of. It wouldn't be a shocking revelation to them, because they're already using machines to prepare their components.
So the end user would do the cutting?
Correct. That way you only have one device, one capacitor on your shelf, rather than 20 capacitors of very small quantities.
An unrelated question, you had said something about 4% equity? Yeah, what's that about?
So in order to license technology from a university, you typically have to give away an equity stake, because they helped fortify or put up some of the additional money. They provided the services to get the technology to where it is today. So the 4% equity is actually a win. Thanks, Bill Grimm, to wherever you are, for teaching me how to negotiate a part of venture scale up. But they actually started out with a 5% equity and a 10% royalty. And for something like an electronic component, a 10% royalty would have killed us. So I was fortunate to get it down to 2%. Yes.
If I can also answer that question, the difference here is this is a supercapacitor. So the capacitance is much higher than a typical capacitor. So that's the hairy structure you can see there. They are all nano whisker. We call them nano whiskers. And that can be easily developed, and that can enhance the surface area, total surface area, and that can multiply your capacitance. So it's a supercapacitor.
Yes.
How much of this has actually been manufactured so far?
So we have proven that the technology works, but think of it as like baking pasta. If you wanted to make pasta for a family of 4, but you only had a 2-inch pot, could you make that much pasta? Not really. We only had a 2-inch pot with the infrastructure that we had. However, we're contracting Sism Thin Films, Jabil, so that we can have access to larger infrastructure, a 6-inch pot, so that we can make pasta for a family of 4 rather than smaller units. So that we know that the technology works. It's about scaling the technology into a mass production process.
And what do you see as your biggest manufacturing challenge in achieving that scale?
I think what he was mentioning about making sure of the tolerance is important. So the way that this will work is you have the nano whiskers and then you coat the nano whiskers with chemicals. We have to make sure that the chemicals are consistent across the wire to make sure that the capacitance isn't a little more capacitive over here and a little less capacitive over there. We're actually working with Sism Thin Films, which has a special sputter coat method to help make that an even layer of the chemicals necessary.
Yeah, and that can be done easily by adjusting the time you give to deposit that layer on the surface of these nanostructures.
Correct.
Okay, and how many people are involved in the company today?
So right now, the equity holders are himself and me,
Okay.
Dr. Thomas and myself.
Yep.
But we're working with Ditech to try and get an equity investment, which will add them. We signed the intellectual property contract, so UCF now has 4% equity, and we are also going to be giving a matching equity fund for Florida Institute of Commercialization, which matches whatever the lead investor does.
And then how do you see, how many people do you think you're going to have in a year or 2 years?
What do you mean by people? Employees, customers?
Employees.
Employees. So I think right off the bat, we're going to need to bring on someone with a strong sales background and someone that has an MBA level operating background. So I would say between those two future employees to help with the business and sales side and the material science expert and the electrical engineer, I would say between 4 and 6 people over the next 2 years.
Okay. And then do you plan on the other folks that come in that 2-year group to be just employees, to be co-founders, to have options, equity? What's the plan to compensate them?
So yes, we have an option pool to help entice future employees, but that's pretty standard for any company. But I would consult with my advisors on how I would actually implement a plan like that. However, we've learned that Orlando is a beautiful place to work. Actually, George Grammatikis back there was just telling a story about how his employees can't get their relatives to go home. So being in a great location like Orlando, as well as having exciting technology that can be as disruptive like this, we haven't had actually a lot of difficulty getting people to want to work with us. As soon as I told Jabil about what we were doing, they were like, oh, I deal with that on a daily basis. They were intrigued. They wanted to be our partner. It wasn't just please be my partner.
And one last question. When you're talking about working with companies like Emerson and APC, are you talking about replacing the capacitor requirements in their power platforms or replacing some of the battery requirement as well?
So Emerson, APC, Mitsubishi, these are large system integrators for power electronics. So what they do is they buy capacitors or they buy a battery and they install it into a system. I would not be trying to redesign any of their products because that makes my barrier to entry much larger. I'm just simply going to give them a replacement capacitor for their electrolytic capacitor. So they don't need to redevelop their product or redo their UL listing or redo their patents. It's just about replacing the vendor of that capacitor.
So it's a direct capacitor replacement. It's not necessarily the density of like a potential battery replacement in its current form.
At the current form, no.
Thank you.
For the time being, it's not our plan, but in the future, that's a very possible thing because these wires, they can transmit electricity as well as it can store electricity. Mm-hmm. So in the future, that is a possibility. And also, it's not only supercapacitor, it can work as a hybrid battery. So it can work both as a supercapacitor, which can give a huge power, as well as the power density is high, as well as the energy density is high. Mm-hmm. Energy density high means it works like a battery.
Right. Thank you.
Okay, thank you.
So we've spent some time in this space. Can you talk to me about the amount of testing done for that architecture related to a supercapacitor?
That would be referred to him.
Because the biggest issue that supercapacitors have is that when they're manufactured in unique ways, and you probably know the same 12 companies that I do. Yeah, well, everyone says that, but they fail, and they fail a lot. And I'm looking at the picture, and the architecture doesn't make me feel great about whether it fails or not. So can you talk to us about how much testing has been done relative to that architecture and over time, varying power up, power down, cycles, that type of stuff that would make me feel better about a wire capacitor?
Yeah, this has been developed in my lab, and also we have developed at least more than 50 devices. Okay. And as he has shown, this has been selected as the cover page of a scientific journal, high impact journal. And they always check all these things. So whether this is possible, even in Nature, there was an article that is the Bible for us, for scientists.
Yeah.
So they tested all those things and they approved that yes, this is a technology that works and it can be reproduced.
Right, if I can answer your question really quick, we've tested the cycles. It's 8,000 to 12,000 cycles were easily accomplished.
Yeah,
and
we checked for 12,000 cycles, but now we are checking it for 30,000 to 50,000 cycles.
Yeah, I mean, these things, the cycling, 8,000 cycles is it's like 0 cycles, right? I mean, the question is it getting to 100,000 cycles,
Yeah,
right?
absolutely.
Right.
well, I can also mention that we bent the capacitor over 1,000 times and it still had 99% efficiency.
Yeah, we did all those tests, bend it and cycle it, some of the current devices that can be cycled more than 30,000 cycles.
Yeah.
And with this high energy density as well as power density, as I said, this can be like a hybrid supercapacitor. So that is very important. But if you think about your battery, you can cycle it only 2,000 to 3,000 cycles with
Yeah.
your battery.
Right.
But by the way, there's a lot less expensive, right?
Yes, absolutely.
And the problems people have had is related to both the manufacturing rigidity and the ability to reproduce it really well. The so the coatings and stuff on the inside, because when those things don't, that looks really hard to coat. So that's why I'm asking.
Absolutely.
So
You're absolutely right.
you're pretty early.
Yes, you are absolutely right. What we have done is we have done the time-based one. So with the 10 minutes, this much thickness is going to be deposited on the nanostructures. 20 minutes, this much thickness is going to be deposited. And with that active material deposition, the thickness, your capacitance is going to vary. And we have done it a number of times and made sure that this works. And this is a technology for actual application.
So listen to this, and just sort of understanding the process you've got to go through. You're years away from revenue. I appreciate Jabil Circuits. You're going to be a customer of Jabil Circuits. As long as you're going to pay them, they're going to do whatever you ask them to do. And Ditech, there's no reason for them not to want to have an interest in the company if you were going to be successful. If you're not successful, even if they invested some money, that's sort of the process. But it's sort of what Jason was. There's a lot going on here that I don't want to call it a science experiment, but there's a lot going. This is not a business yet, and you're reasonably far from it. I'm not trying to water down the presentation. You did an excellent presentation. It's probably the best one we've seen tonight. But it was a great sales job. I think this is a great idea, but it's not. And I don't want to say it's not in my lifetime for an investment. It's still a ways away.
Okay.
I know you don't agree, but
That's your,
I mean that's
your
so,
opinion.
right. I mean but that's sort of what it looks like.
Okay. Well,
Okay.
I would say that we're currently working with.
All right, and so Joe, no criticism of you, but you've got no corporate business experience. I mean, you're a good guy, went through school and probably did a great job at it. But taking a product like this to market is not simple. Creating it is hard, I agree, but in a laboratory environment, you can create a lot of things. This is a tough deal what you have to do to go forward. I give you guys a lot of credit for wanting to go through it, but this is going to take a lot of investment to get it where you want it to be.
Okay.
Yeah, well, one, I was just going to say congrats. Sounds like you guys surrounded yourself with a good board. I mean, I would echo some of the sentiments here that my little piece of advice is, I don't know how active you're using some of the board members, but certainly the people who've invested in scaling businesses like this and really figuring out the go-to-market time. I was going to say what my colleague Richard said, but in a slightly more optimistic way. Right? I was going to say you would need somebody on your team that understands how to commercialize something like this faster than the time frame that you had it in there. Because I think the technology might actually work. I just feel as if, first of all, the funny thing with a lot of these patents, they're like a couple ways to skin the cat. I'm sure it probably does work, but it doesn't necessarily mean it is the only way to build a supercapacitor with some of the flexibilities, right? So that's one. And then
really think about what it would take to really take this business to the next level, and how do you reduce that time, because you don't want him sitting around here waiting 10 years before you're ready for him to invest.
Right, and as I mentioned to him, I do see adding more people to the team, and I mentioned a chief operating manager who would obviously need to have a background in commercializing technology like this. Those people do exist, and so I agree with both of you. It is a difficult market to do, and that is why we put a lot of value in having Ditech as our as our launching partner, because they could be the first customer as well. And so we plan on starting there, getting the case studies, and using that data to extrapolate to larger and bigger things.
So if I can add, the strength of our technology is a product. This is a first product which can transmit electricity and at the same time it can store the energy. That is the strength. That is unique. But in supercapacitors, you can see so many supercapacitors out there. But a technology like this, which can be used for solar in the future, solar energy, which is going to be transmitted to the grid.